Good morning to everyone. Myself, V. Dilip Kumar, Assistant Professor, Department of Computer Science and Engineering, SRK Engineering College, Bhimavaram. In this video, I am going to discuss about Advanced Encryption Standard. In previous video, we are discussing about the Data Encryption Standard. The Advanced Encryption Standard is formal encryption method adopted by the National Institute of Standards and Technology of the US government in 2001. It is accepted worldwide. DES was not considered secure because of advances in computer processing power. Thus, in 1997, the National Institute of Standards and Technology (NIST) invited cryptography and data security specialists from around the world in order to find a new algorithm for replacement of DES. Belgium cryptographers Rizman and Damon proposed an algorithm named Rizdal. After adoption, the encryption algorithm Rizdal was given the name Advanced Encryption Standard, which is in common use today. The objectives of this video: to define basic structure of AES, to define transformations used by AES, to define the keys acceptation process. AES Cipher. In AES Cipher, we are using different keys from 128-bit, 192-bit and 256-bit, and the plain text block size is 128-bit. The number of rounds are dependent on the key size. For 128-bit key, 10 rounds of operations. 192-bit key, 12 rounds of operations. For 256-bit key, 14 rounds of operations. Encryption process. In here, the plain text is undergoing to the substitution bytes, shift rows, mixed columns, and add round key for each round. Here 10 rounds of operations. The plain text size is 128-bit and the key size is also 128-bit. Here we are getting the keys in the words 0 to 3 means 4 word keys. Here total 44 keys. This is the encryption process and this one is the decryption process. The key that is provided as input is expanded into an array of 44 32-bit words W of I. 4 distinct words serve as a round key for each round. 4 different stages are used. 1 permutation and 3 substitution operations are done. The first one is substitution byte, shift rows, mix columns, and add round key. Substitution of bytes. The 16 Input bytes are substituted by lookup table, a fixed table as box given in design. The result is in a matrix of 4 rows and 4 columns. Shift rows. Each of the 4 rows of the matrix is shifted to the left. Any entries that fall off are reinserted on the right side of row. Shift is carried out as follows. In first row, there is no shift. In second row, shift 1 byte position. Here A10, here A11. A11 is shifted to 1 bit position. And in second row, 2 positions are shifted. And in fourth row, 3 positions are shifted to left. Finally, we are getting the 4 by 4 matrix. And mixed columns. Each column of 4 bytes is now transformed using a special mathematical function. This function takes as input the 4 bytes of one column and outputs 4 completely new bytes, which replace the original column. The result is another new matrix consisting of 16 new bytes. It should be noted that this step is not performed in the last round. The resultant column and mixed matrix using 128-bit key. This is the original column and this is the key. This is the resulting one. Add round key. The 16 bytes of matrix are now considered as 128 bits and are XORed to the 128 bits of the round key. If this is the last round, then the output is the ciphertext. Otherwise, the resulting 128 bit are interpreted as 16 bytes and we begin another similar round. Decryption process. The process of decryption of an AES ciphertext is similar to the encryption process in the reverse order. Each round consists of 4 processes conducted in the reverse order: add round key, mixed columns, shift rows, byte substitution. The difference between AES and DES. Data encryption standard block size is 64-bit plain text. Here block size is 128-bit plain text. Key size is 56. Here the key size is varies from 128, 192 and 256. DES divides plain text message 64-bit blocks each and encrypt using 56-bit key. AES divide plain text into 128-bit block each and treat each block as a 4x4 array. The block is then encrypted using one of the 3 different keys. Those are 128, 192 and 256-bit keys. Number of operations undergoing 16. Here number of operations are vary based on the keys. 10 rounds of operation for 128-bit key, 12 rounds of operations for 192-bit key, and 14 rounds of operations for 256-bit key. DES was designed by IBM. AES was designed by Vincent Risman and John Damon. DS is slower. AES is comparatively faster. DS has a smaller key which is less secure. AES has a large secret key comparatively, hence more secure. Here AES uses only the shifting operations and XOR operations, so it is more faster. Steps undergoing expansion permutation, XOR, S-box and T-box, XOR and swap. Here steps are substitution of bytes, shifting rows, mixing columns, and add row round key. Summary. The encryption algorithm principle was given the name Advanced Encryption Standard. Encryption process. Substitution of bytes, shift rows, mixed columns, add round key. Decryption is similar to encryption, reverse process, but not same. Thank you.